Hi, welcome to NumPy Tutorial Series. This is the second part of lesson on NumPy Array Slicing. In this part, we focus on two-dimensional arrays and compare how array slicing differs from Python list slicing. I assume that you are already pretty comfortable with slicing in one-dimensional array. If not, please check the link in description below to see part 1 of this lesson. Please subscribe to Badger the Teacher and never miss new educational videos.
I think slicing in two-dimensional arrays is very similar to one-dimensional array slicing.
Right. The only difference is quite intuitive. You should provide start index, stop index, and step for each dimension. The row dimension is always the first one. In this example, we have two-dimensional array with 3 rows and 4 columns. Keep in mind that Python uses zero-based indices. 3 rows from 0 to 2 including, 2 columns from 0 to 1 including. Let's say this time we take rows starting from 0 till 3 and columns from 0 till 2. It results in all rows and only 2 first columns. Like with the one-dimensional array, you can omit some parts and use default values. Again, default value for starting index is 0, dimensional size for end index, and 1 for step.
So, this example can be rewritten in a shortened format. As we take all the rows, we can omit all the parts. For columns, we have to define end index, which is 2.
Similar to one-dimensional array, you can reverse two-dimensional array as well. You just have to pass 2 colons minus 1 in both row and column dimensions. We have already discussed in the part 1 of the lesson that this approach is equivalent to the dimension size (none, -1), because default values are swapped in this case.
I recall that if we use 0 as stop index instead of none, it is not included and the first element gets lost.
Exactly.
Can we mix indexing and slicing together?
Yes, you can pass particular row or column index while slicing the second dimension. The first example is asking for all the rows and column of index 0. These are elements 0, 4, and 8. The second example, on the other hand, is asking for row with index 0 and all its columns. So we get all the elements of the first row, 0, 1, 2, and 3. The last example actually is the same as the previous. You can use just row index without column. However, this is only applicable to rows. You can't get particular column this way. Let's discuss one very important difference between NumPy array slicing and Python lists. In lists, slices are copies.
What does it mean?
Let's say we have a list of 4 elements, 0, 1, 2, and 3. We create a slice with only even elements and assign it to slice variable.
So slice variable contains a list with 2 elements, 0 and 2.
We then modify the element with index 0 and set its value to 1.
After this operation, in slice variable we have a list with 1 and 2.
Let's check what we see in the original list. It has not been changed. 0 is still the first element there.
So, do I understand correctly that main idea is that modifications in slice don't affect the original list?
Right, and it's because a slice is a copy.
Let's compare it with NumPy arrays.
Array slices return views, not copies of the array data. So NumPy array slicing differs from Python list slicing. Again, we have the same elements, but now stored as an array. We then take even elements and store them in a slice variable. Again, we modify the first element in a slice variable, set its value to 1. After this operation, we check the original array and see the first element has been changed.
Something to keep in mind.
What can help you remembering this is understanding that NumPy is intended for large data scales, so it won't be effective to create copies instead of views where it's not needed.
Is there any possibility to make a slice as a copy in NumPy?
Yes. If you need a slice to be a copy, not a view, you should explicitly call copy function. In this case, you see, again, we take a slice with even values, saying that we want a copy, assign this array to slice variable, and then set the element with index 0 a new value, 1. After checking original array, we see that it has not been affected by this change. We cover broadcasting in another video, however, let's just see a small example. Here, I just want to show you how convenient broadcasting is with slicing. For example, you can take a slice and assign all its elements the same value.
So it means here we take a slice of index 1 and 2 and assign value 12 to all sliced cells. As a result, we have only 0, 12, 12, 3 in the original array.
That's it for today. Please practice accessing subarrays with slicing. In the next lesson, you will learn what fancy indexing is. Please subscribe to Badger the Teacher and don't miss new lessons. See you in the next lesson. Bye!